Alaikum. This is Chemistry 11th, and our today's topic is this characteristics of ionic compounds. Dear students, as we have already discussed this ionic bond or electrovalent bond in our previous lecture, and we have also discussed the factors that which um, which are essential for the formation of this ionic bond, like we have this the ionization enthalpy, then we have got this electron gain enthalpy, then we have got the latest energy or latest enthalpy. Now depending upon these factors, depending upon no, these factors, say latest energy, we have got electron gain enthalpy, we have got this ionization enthalpy. The stability of an ionic compound depends upon these factors. Now, as far as if the magnitude of this lattice energy and this electron gain enthalpy is greater than the ionization enthalpy, in that case the bond formed is very strong, or it would be a stable one. Now, as far as this the value of these two are concerned, if the value of this electron gain enthalpy and this lattice energy, if they are less than this and this ionization enthalpy, then the bond will not be formed. This ionic bond will not be formed. Now, as far as the characteristics of this bond, this ionic bond, or this characteristics of this ionic compounds are concerned, we have got this physical state, we have got this melting and boiling points, then we have this electrical conductivity, then we have got the solubility, and then this ionic reaction. Now, as far as this physical state is concerned, these ionic compounds, they exist as crystalline solids, in which we see that the oppositely charged ions, they are closely packed in space. Now, this type of arrangement, as I have already told you, that this arrangement we call it as, or this is known as crystal lattice. Now, the nature of this crystal lattice, it depends upon the size and the charge of the ions. Now, as far as these compounds are concerned, these ionic compounds, they don't exist as they do not exist as single molecules, like we have this hydrogen, H2 or N2 or oxygen, but instead they exist as a network of ions, and as a network of ions. Now, the crystal lattice, in the crystal lattice of NaCl, or which is we call as the rock salt, here you see that the chloride on these ions, they occupy these corners, and then we have got sodium ions. This is sodium ion, this is chloride ion, this is it has got a cubic structure, and this is the lattice structure of this our this common salt, which is also known as rock salt. In short, I would say that as far as the physical state is concerned, these they exist as crystalline solids. Now, then we have this melting and boiling points. Now, as far as the melting and boiling points of these solids or ionic compounds are concerned, because as the interionic forces in these ionic compounds, they are very strong. So on account of this, they have got very high melting and boiling points, now this, because of these strong ionic attractions, and the melting and boiling points are strong, and also this leads to close packing of the ions, these oppositely charged ions in the crystal lattice. Then another property we have, that is the electrical conductivity. As far as the electrical conductivity of these ionic compounds is concerned, we know this since these ionic compounds they are formed, or these are formed of ions, and we see that the bond being stronger, these ions are, they are held at their respective positions, and they are not free to move. So in solid state or in crystalline state, in these crystalline solids, we see that or in these ionic solids, we see that they are, the electrical conductivity, it is almost nil, because ions are not free, or they are not free to move. Now since the ions are not, however, in molten state, or we say in fused state, or when these ionic solids, they are dissolved in a solvent like water, these behave then good conductors. This is because now once they are dissolved in these solvents, in ionics, in polar or ionic solvents, the ions become mobile, and therefore they behave as good conductors. And so only in this molten or in fused state, or in aqueous state, aqueous form, that these the electrical conductivity is observed in these ionic solids, in case of these ionic solids. But in solid state, this conductivity is almost nil. Now, as far as the solubility of these ionic compounds is concerned, now solubility, ionic compounds generally get dissolved in polar solvents. Polar solids like water. The polar molecules of the solvent, they interact with the ions of the crystalline solid, as a result of which energy gets released. Now, if the solvent used is water, then the energy released, we call it as, that is known as this hydration energy. Now the energy that is released, it overcomes the it in this the energy which gets, this hydration energy, or the energy which gets released, this overcomes the interionic forces, and thus ions get separated and go into the solution. Now, as far as their solubility in case of organic solvents is concerned, these are insoluble in organic solvents, like we have this benzene, we have got this ether, we have got CC, carbon tetrachloride. This is because of the non-polar nature of these solvents. Now then we have got the ionic reactions. Now, as far as these ionic reactions are concerned, ionic reactions, the ionic compounds, since these ionic compounds, they contain ions, so obviously their chemical reactions, they are ionic in nature. Now these ionic reactions, they are very fast and do not require these specific conditions. For example, if we see the reaction between silver chloride and this sorry the reaction between this sodium chloride and silver nitrate, aqueous solution of this sodium chloride and aqueous solution of this silver nitrate, this reaction is very fast, and it results in the formation of a white precipitate of this white precipitate of this silver chloride. Then this is about, these are the characteristics of these ionic compounds. Then we have got another type of this chemical bond, which is known as covalent bond. So various now, as far as this covalent bond is concerned, it was actually Lewis, in collaboration with Langmuir, he introduced the concept of this covalent bond, and various theories have been put, like Lewis Langmuir theory. We have got Valence bond theory. We have got molecular orbital theories. Now, before going through these theories, I would like to say first of all that what this covalent bond is. As we have seen that in case of ionic bond or in electrovalent bond, there is transfer of electrons takes place and ions are formed. But unlike this ionic bond, in case of covalent bond, we see this bond is formed by sharing of electrons between two atoms. Now there may be sharing of one pair of electrons, there may be sharing of two pairs of electrons, or three pairs of electrons may get shared between the two atoms. Now, as far as the nature of atoms is concerned, nature of the concerns, this covalent bond, it may be formed between two similar atoms, or it may be formed between two different atoms. If this covalent bond is formed between two similar atoms, then a homoatomic molecule is formed. uh, or if this bond is formed between two different atoms, then a heteroatomic molecule is formed. Now, depending upon the number of electrons shared between the two atoms, we have got various types of these covalent bonds. We have got a single covalent bond, we have a double covalent bond, we have a triple covalent bond. For example, in case of this, if you take the example of these homoatomic molecules, for example, hydrogen, we have got chlorine, and in this case we see hydrogen has got a single valence electron, and same is the case with this hydrogen atom. Now, these two electrons, because of their similar this electronegativity value, the electrons, they share the two hydrogen atoms share each electron, and this shared pair, it is held common between these two hydrogen atoms, and it is equidistant from these two hydrogen atoms, and thus results in the formation of this single covalent bond, that is H and H. Now, similarly is the case. Similarly, we see this is a homo diatomic molecule, Cl2. Again, we see here there is a single covalent bond formed between these two chlorine atoms. Again, we see that this shared pair, it is held in between the two, and is equidistant from the two atoms, and gives rise to the formation of a single covalent bond between chlorine and chlorine. This is due to, because again we see here the electronegativity, they have got the two chlorine atoms are of same, they have got the same electronegativity value. Now, then we have got a double covalent bond. In case of a double covalent bond, we see two pairs of electrons, they get shared between the two atoms. The best example is here this oxygen molecule. Again, we see the way, in the valence shell of oxygen atom, we see that there are six valence electrons. Now this oxygen atom, it is short of two electrons to complete its octet. Another oxygen atom having again six electrons, these two, they approach each other, and they share these two pairs of electrons, and giving rise to a double covalent bond, that is O, double bond O. Then we have got another this homoatomic molecule, that is nitrogen, in which we see there is a triple covalent bond. Three pairs of electrons get shared between these two nitrogen atoms. Here, in case of this nitrogen, we see that there are five valence electrons. Again, in this case, we see there are five valence electrons. Now, after forming these three covalent bonds, in the octet of this nitrogen atom, it also gets complete. It now has got eight electrons. Same is the case with the other, and this other nitrogen atom, which two has got eight electrons in its octet. Now, after forming these three covalent bonds, so this leads to formation of this N2 molecule. This is a N2 molecule. So this is a homodiatomic molecule. As far as the hetero these molecules or heteroatomic molecules are concerned, we will discuss it in the next lecture. Thank you very much.